and welcome to my C# course. In this course, I want to teach you how to use the C# programming language effectively. But this is not an introduction to programming. I expect you already know a little bit about programming. So if I talk about a loop or an array, I hope you already know a little bit about those concepts from another programming environment. My goal is to teach you about the C# language, and I want you to follow along with the demos that I do in the videos, because I believe that typing and writing code is about 30% of what you have to do to learn a language. Another 30% is experimenting with the code that you write by changing that code and really understanding how it works. The last 40% of what you do to learn a language is to read other people's source code. Throughout this course, we're going to build a small application to store the grades for a class of students. And by the time we're done, you'll be able to create your own projects based on your own ideas. Since I want you to follow along, let's talk about the tools I'm going to use. In this course, when I'm demoing the C# language, I'm going to be using the language on top of a runtime and a framework known as .NET Core. In order for you to follow along, you are also going to need to download what is known as the .NET Core SDK, or Software Development Kit. This SDK provides all of the tools that I need to convert a program written with the C# language into a program that I can run on my computer. So if you go out and do a search for .NET downloads, you should be able to find this page on the Microsoft.com website with links to download .NET Core. And .NET Core is available for different operating systems, Windows, Linux, and Mac OS. So .NET Core runs nearly everywhere. And you just want to look for the link that allows you to download the .NET Core SDK. Now in this course, I'm going to be using a specific version of .NET Core. I'm going to use the latest released version, which is 2.2. And all the code that I'm going to write in this course, I expect to work in future versions of .NET Core and C#. So if you want to download the latest version of .NET Core, if there's a later version available by the time you watch this video, then feel free to download a later version. But if you're very conservative and you want to use the exact same version of .NET Core that I'm using, because there always will be small changes, but you can always find older versions of .NET Core in the download archives from this page. So just look for archives, go to that page, and older versions of .NET Core will be available. So if we're currently on .NET Core 5.6, you'll be able to go back and find a download for the .NET Core 2.2 SDK. Now, in addition to the SDK, there's just one other tool that I need. I need some sort of editor, somewhere where I can write and type in C# code. And in this course, I'm going to be using Visual Studio Code. Visual Studio Code, just like .NET Core, is available on Windows and Mac OS and Linux. So you can use Visual Studio Code as an editor with the C# language on just about any platform. If you do a search for Visual Studio Code or VS Code, that should bring you to this web page at visualstudio.com, and you should be able to find a download button. And from there, click on the download associated with the platform that you're using. On this machine that I'm using, I've already installed Visual Studio Code. I've already installed the .NET Core SDK. So let's start a journey towards writing our first program. Before we start writing our first program, however, I do just want to spend a little bit of time talking about the environment that we'll be using, which is .NET Core. This is a course about the C# language. So we will be creating software using the C# language. But what is going to run our software? Because I cannot just put C# code into a file and expect an operating system or a CPU to understand the instructions inside. There has to be a runtime or a framework that can take my C# code and tell the computer what to do. And that framework we are looking for with C# is called .NET. Now, if you've done any reading or research about the C# language already, you might have come across two different .NETs in the world. And I just want to take a quick moment to explain the different types of .NET to give you a better understanding of what we'll be doing. When people refer to .NET, just .NET, or they refer to the .NET framework, they are probably talking about a version of .NET that works only on Windows machines. This is the .NET framework that has been around since about 2001, and it is the .NET framework that often comes pre-installed on Windows, and it's a framework that is authored and supported by Microsoft. .NET Core has been around for just a few years, but .NET Core refers to a .NET that is completely open source and works across various platforms like Windows, Mac OS, Linux, and even runs on a small Raspberry Pi computer. Both .NET and .NET Core support the C# language, but it is .NET Core that you probably want to be using if you can in any new projects today. .NET Core is certainly what we're going to use in this course. So what is inside of .NET and .NET Core? How do they support the C# language? Let's talk about that next. We're going to write some C# code in just a moment, but as I mentioned before, I cannot just give my C# code to the computer and expect the computer to execute my program. There has to be some additional software in place that knows how to translate this C# code into instructions for my machine, my operating system, and my CPU. This is true for any high-level programming language. Java, Ruby, JavaScript, Python, they all need additional software to execute the instructions that you are writing in that language. As I mentioned for C#, this software is what we call .NET, and you can really break down .NET into two pieces. First, there is what we call the CLR, which is short for Common Language Runtime. That's a fancy term, so all I want you to remember is that .NET is a runtime, which means .NET provides a space for you to run your programs in C#. So .NET knows how to bring your program to life and manage memory for that program and send instructions to the Intel or AMD or ARM processor that's in your computer. And actually, .NET provides a space to run not just C# programs, but there's a number of other languages that work on top of the .NET runtime, including Visual Basic .NET and F# and others. The second piece of .NET is what we sometimes call the FCL, or Framework Class Library, but there are lots of names that you might hear for this part of .NET, including Base Class Library, but the most important word to remember is the term library. In addition to a runtime, .NET also provides a library of code that is already written and tested by other developers, Microsoft developers and non-Microsoft developers in .NET Core, since .NET Core is a true open source project. You can use the code from this library in your C# program to perform common activities, like if you need to communicate over the network with HTTP, or if you need to encrypt and sign a message, or you need to open a file. Those are all activities that are already written for you, and you can take advantage of them from your program so that you don't have to spend your time writing all the low-level code that is already in the .NET library. So now that we know a bit about .NET, let's use a tool from the .NET SDK to create our first project. The SDK that you downloaded, by the way, includes a .NET Core runtime and all the files that you need for the .NET Core library, as well as some additional tools that make developing software in .NET easier, and that's why we call it an SDK, a software development kit. Let's take a look. Once you have the .NET Core SDK installed, you should be able to open a command prompt to use something we call the .NET CLI. CLI is short for Command Line Interface. So you can open a command prompt or a shell or a terminal. Really depends on what operating system you're on. And if you're on Windows and you've never opened a command prompt, go to the Start menu, type CMD, and one of the entries that should be available is Command Prompt. In this course, we only need to perform some very simple operations in the command prompt, but what I want to do is interact with a tool known as the .NET CLI. The name of the program that I want to run is .NET. And after you've installed the .NET Core SDK, this program should be available from any place that you are on the file system on your computer. In other words, this tool should be in your path so that I can run this program from anywhere. And you can see when I execute .NET, the program is saying, look, I either expect some options or I expect a path to an application. Let's try some options first. One of the options I can pass in is --info. This provides some useful information if you're trying to troubleshoot your environment, because what --info will do, if I scroll up a little bit, it will tell me what version of the .NET SDK I'm using. In this case, I'm using version 2.1. It will also tell me about my runtime environment. Yes, I'm on Windows 10, a 64-bit version of Windows 10 running on a 64-bit processor. And the version of the .NET runtime that I'm using is version 2.2.1. So yes, the version of the SDK and the version of the runtime will be different, because the SDK version is the version of the tools that I'm using to target .NET for development, whereas the runtime version is the version of this runtime and framework, this library that I'm using to execute my .NET programs. And down here I can see the versions of all the SDKs that I have installed on this machine and their location. as well as all the .NET runtimes that I have installed. So 2.1.0 all the way up to 2.2.1. Let's try a different option that will tell us a little more about what .NET can do. I'm going to pass in a -h for the help or documentation for this tool. I can also pass in --help. And this will tell me the different SDK commands that are available with .NET. So for example, if I wanted to build a project, I could type the command .NET build. We're going to see how to build a project in this module because a build is something I have to do when I have C# code inside of a file and I want to run that C# code and execute it as a program. First, I will have to build that source code into another file that the .NET runtime can load and execute on my machine. So .NET build is one command. You can see a number of other commands here. Here's .NET test. In this course, I'm going to show you how to write a unit test for your C# code. Unit tests are invaluable for writing code to ensure that your C# code is working as expected. They're also an invaluable tool for a beginner because creating a unit test project allows you to experiment with C# code. You can experiment and figure out how things work with unit tests, and that's something I highly encourage. There's also a command I can execute .NET new to create a new .NET project or file. So let's back up a step and talk about a project. What is a project? A simple description of a project is that it is a collection of source code files that you want to put together into a single application or a single library that you write to share your code with other developers. So before I can create an application, I first have to create a project with some source code for the application. And to do that, I'm going to execute the command .NET new. This is going to come back with some additional information that I'm required to pass in to .NET new. Let's talk about this in the next clip. At the end of the last clip, I had gone out to the command prompt and typed the command .NET new. And .NET new came back and essentially said, what is the template that you want to create this new project? So a template is something that I can use to stamp out the basic structure of a new project for an application with the .NET CLI. And all I need to do is specify which template that I want to use. So if I want to create an application that I can run here in the command prompt, then in .NET, that type of application is known as a console application. It runs here in the console, which is just another word for this textual environment that we call the command prompt, and on other systems, it's known as the terminal or the shell. So if I want to create a console application that will run here on the command prompt, I can type .NET new console. On the other hand, if I wanted to create a project full of unit tests, I could type .NET new MS test. I could also create a new web application using a template for ASP.NET Core. That's a web programming framework built on top of .NET Core. And in that case, I could type .NET new web. So in each of these cases, what .NET new will do is create the basic project structure that I need for the type of application I'm building, whether it's a console application or a unit test or a web application. What we want is a console application. So I'm going to come back to the command prompt and clear everything out, and we're going to create a new directory where I can create my application. So in Windows, I can type mkdir for make a directory. That also works on other operating systems. And I want to create a directory called gradebook. Because as I mentioned in the introduction to this course, we're going to build an application that will store the grades for students in a class. So let me use the cd command to change directory into the gradebook directory. I can see this directory is completely empty, and I could create my project here, but I'm going to make just a couple more directories inside of the gradebook directory. So I'm going to make a directory called src, which is short as a convention for source. This is where I'm going to keep my source code. And I'm also going to make a directory called test, and that's where I'm going to place my unit test code. Now, we're not going to write a unit test yet in this first module, but we are going to create the basic console application inside of the source folder. So let me change directory again into the source folder. And it's inside of here where I'm going to create another directory named gradebook. And I'll do that with some capital letters. So it's inside of this folder where I want the project for my main application. And the name of that application is going to be gradebook. Let's change directory into gradebook. In really large projects, you can have dozens of directories inside of the source folder. And each of the directories inside of here can represent a project that is part of a system. It could be an individual application, or it could just be a component that is part of a larger application. We're going to build a relatively simple system that consists of just this application project and a unit testing project, but I'm trying to show you a conventional directory structure that you will see for .NET Core projects and .NET Core solutions. So it's here inside of gradebook /source /gradebook, where I will use the .NET new command to say that I want to create a new console application. So I type .NET new console, I press enter. I'm going to see a number of logging messages scroll by, and I should now have in this folder a number of files. So I'll tell you right now that gradebook.csproj, the csproj extension means this is a C# project. So this .csproj file can contain information about my application, about my project. I also have a program.cs. This file is going to contain some C# source code that is already a part of my console application. We're going to look at it in just a minute. But before we look at any of the code, I just want to run the command .NET run. Now, if I press enter, what .NET run is going to do, since I haven't given .NET run any other information, it's going to look inside of the folder that I'm currently in for a project, and it will find gradebook.cs project. And what .NET run will do is say, oh, you must want to run this project. So let me try to take all the steps that are necessary to execute the code that is part of this project. And we can see the result of .NET run on this brand new console application is to say, hello world. So now that I have my first project, and I know this project works because it creates the expected output, which is hello world, now let's talk a little more about a couple different topics here. Number one, how can I edit this project and make changes to this application that I've already built? How could I make it say, hello Scott, for example? And I also want to talk a little bit about what's happening behind the scenes when I do a .NET run. I want to change my application, so let's start our editor, Visual Studio Code. From the command prompt, what I want to do is back up a couple of directories. So .. to move up one directory, and then I want to move up one additional directory, so another .. and that should put me in my gradebook top level folder for this system, for this application. And it's from here where I want to launch my editor. So I'm going to use Visual Studio Code, but you can use Visual Studio on Windows, or you can use Atom or Sublime, or really any editor. I'm going to use Visual Studio Code, so I'm going to type the command code and then period. When you install Visual Studio Code, you're given the option to add code to your path. That allows you to type the command code from anywhere on the file system to launch Visual Studio Code. So that's what I'm going to do here, launch Visual Studio Code and tell it to start in this current directory. That's what the dot means. Start by opening this gradebook folder. If for some reason you do not have Visual Studio in your path, then go ahead to your Start menu or your App Organizer and start Visual Studio Code, and then just go to the File menu and say that you want to open a folder and browse to that top-level gradebook folder. So don't go into the source folder where the CS project file exists. Go to the top-level folder. What I want to see over here on the left in what we call the Explorer window is a complete view of the file system, including the source folder and the test folder. Now, over here on the right-hand side, the bottom right, there was an alert that appeared for just a moment. I'm going to reopen that alert by clicking on the notification icon here at the bottom. And this notification says that required assets to build and debug are missing from the gradebook. Do I want to add them? Now, if this is your first time using Visual Studio Code, you will probably not see this notification. What you need to do is first install an extension that I use to work with C# source code. And then moving forward, working with C# will be a lot easier. So inside of Visual Studio Code, what you should do is go to the Extensions tab. You can also get there by pressing the shortcut key Control+Shift+X on Windows. And what you want to do is search for the C# extension. So I can just search for C#. There will be an install button for me to click on. And once that extension is installed, I can restart Visual Studio Code. My extension will be installed, and the next time I start Visual Studio Code with the gradebook folder open, I should have this prompt that assets to build and debug are missing from gradebook. I'm going to click yes. I do want to add them. This is just going to make it easier to run and debug my applications from here inside of Visual Studio Code and just never leave Visual Studio Code. We'll see how to do that. Once I've done that, I'm going to come back to the Explorer view, which shows me the file system, including program.cs, which is currently open. If not, I can click to open program.cs, and it's pretty clear where the text hello world is coming from when I run this application. Now, as we work through the course, I'll explain some of these other identifiers and keywords that you see in this file. But for right now, I just want to say that this sequence of characters that is inside of the double quotes is what we call a string in C#. There's strings in lots of programming languages, so perhaps you're already familiar with strings. But I just want to delete the word world and replace it with Scott, but feel free to use your own name inside of the program. Then I'm going to save program.cs, and then I'm going to come back to my command prompt, and once again I'm going to type .NET run because I want to run my project. But now, since I am not in the same folder as my CS project file, .NET run is going to give me an error and say, sorry, I couldn't find a project to run. Make sure there's a project that exists in this folder, or pass a path to me about where I can find the project with -- project. So I can either change directory into the source gradebook folder, or I can say .NET run -- project. Inside of the source folder, you will find gradebook, and look in there for a CS project file. And now my project runs and it says, hello, Scott. So this is a good start. We've already seen how to use the .NET CLI, and we've seen how to use Visual Studio Code to edit C# code, and we've seen how to run and test an application directly here from the command prompt. So now let's start working with some additional changes to our application. But before I do that, I do just want to talk a little bit about what's happening. What is the magic behind .NET Run? What is happening behind the scenes? Let's talk about that next. I just want to take a moment to explain a few of the things that are happening behind the scenes when I do a .NET Run. First of all, I'm going to switch back into the gradebook folder where my CS proj file exists, so I don't have to pass the -- project parameter to all the commands I want to execute, because it's from here where I can just type .NET Run, and Run will find that CS project file. It says, here's the project that you want to run, and it ultimately executes the code that I've described in my C# source code file. But there's a few things that need to be in place before my application can execute. The first thing that really happens behind the scenes implicitly when I do a .NET Run is what's known as a .NET restore. So in the world of .NET, there is a package system known as NuGet. A package system allows my application to take advantage of features and functionality that are in other bits of code that other developers have written. And these bits of code live inside of files known as NuGet packages. So yes, the library that .NET Core provides has a lot of features that allow me to open files and do cryptography and talk over the network, but it doesn't cover everything that I could possibly want inside of a .NET application. So other developers, including Microsoft, will place code inside of NuGet packages and make these packages available from what's known as a package feed somewhere on the internet. Whenever my application needs a feature that is in a NuGet package, I can tell .NET Core that I need such and such a package. That fact is going to be recorded in my CS proj file. So what .NET Restore is doing is looking through my CS proj file to see if I have any of these external dependencies. And yes, many major programming language environments have this package functionality. So in the world of Node, there is NPM. In the world of Python, there is pip, and so forth. We don't have any packages referenced from our CS proj file, but as we move through the course, we're going to see how to work with NuGet packages because they are an essential part of development. Now, once the restore is complete, what a .NET Run can do, again, implicitly behind the scenes, is a .NET build. The restore has to happen first because I need to grab all these other dependencies, these little bits of code that are in NuGet packages. I have to grab those so that when I execute a .NET build can see the full picture of my application. The primary job of .NET Build is to compile my source code. Perhaps you've heard of this term compile or compiler before. The C# compiler that is running behind the scenes is a tool that can analyze my C# source code and transform or translate that source code into an efficient binary format that is faster to execute when I need to run my application. So the C# compiler can come along, look at all of the C# source code that is in my project, all of the .cs files that I have on the file system, and take all of that code and produce a single output file that is a binary representation of my source code. So it's binary format. It's not something that I would ever want to open and read, but it is an efficient format when I need to run the application and actually have instructions execute on my computer. The file that .NET Build produces is this file gradebook.dll. Now, if you've worked with Windows for any length of time, you might recognize the .dll extension as something meaning Dynamic Link Library, but don't think of it that way in .NET Core. In .NET Core, this is what we call an assembly. An assembly is the output of the C# compiler or the VB compiler or whatever language that you're using. It's the output of .NET Build. It contains my code in binary format inside of that file. And you'll notice it's in a folder called bin. Bin is short for binary. It's in, furthermore, a debug folder, which just means this is a debug build of my application. It's going to be a little easier to debug, and we'll debug this application in just a little bit later. And then it's in a folder called Net Core App 2.1, because I have built this using the .NET Core SDK version 2.1. You'll also notice in this gradebook folder, there's another folder named OBJ, that's short for object or object files, and that folder really just contains some temporary files that are put together during the restore and build process. It's a folder that you can safely delete, and actually you can delete the bin folder too if you want to. All you need to keep around is your source code and the csproj file. As long as you have those files, you can always do a .NET build and recreate all these other folders and all these other files. Now, what's interesting about this gradebook.dll file is that I can go out in Windows and try to execute that file. So let's go into the bin folder, debug folder, Net Core App 2.1, and then go to gradebook.dll and press enter. And my file, my program, tries to execute, but it has this error message: could not load file or assembly system.runtime. The way to think of this is that gradebook.dll could not find a runtime that it requires to execute. That runtime is the .NET Core runtime, and that's why if I want to execute gradebook.dll, I have to go through the .NET CLI, which will provide the proper runtime and launch my application. And there's two ways I can do that. From this folder, I can type .NET Run, and what .NET Run will do is make sure it's done a restore, we have a build, and then it will find gradebook.dll and load it. Or I can use this .NET command and go directly to gradebook.dll. So if I go into bin debug and Net Core App 2.1 and then pass the parameter in gradebook.dll, this is a way of saying I want to run something using .NET Core. Please go to this assembly, gradebook.dll, and execute the code inside. And there you can see I get hello Scott. And this command is something that you'll find across a variety of different programming environments. So when I want to run a Node program, I say node and then some .js file. In that case, Node, there's no compiler. I'm executing directly from the source code, but languages like C# and Java that are both compiled, well, with Java, the way I would launch my application is to say Java space, and then the name of a jar file that contains compiled code. So .NET very similar to Java if you come from a Java background. And hopefully this section just demystifies a little bit some of the files and some of the things that are going on inside of .NET Core and with the C# language that you might see. But now what I want to do is come back to the editor and look at adding some features to our application. Here's what I want my application to do before we leave this module. I want the ability to pass my name as a parameter to my application. So I don't always have the application saying hello Scott. It could say hello Scott or hello Alan or hello Sue or hello Jason. I can have this application say whatever I want as long as I pass that name parameter to my application. How are we going to do that? Well, let's concentrate just on these few lines of code here inside of the file. So first of all, I am inside what's known as a method in C#. This method name is main. We'll talk about some of these other keywords of the C# language that we're seeing here, like static and void. But for right now, I just want you to know that this is a method. Inside of the curly braces, I place the code that I want to execute when this method is invoked or called. And how does this method get called? Well, when I launch a command line application, a console application in .NET Core, by convention, what we call the entry point of the application is a method named main. So in other words, when I type .NET run or I say .NET and then gradebook.dll, what the .NET runtime is looking for is a method named main, and then it says, oh, this is the entry point for the application. Let's start executing the code that is inside of that method. And the code inside of this method currently says, please go to the console and write out the following text, which is hello Scott. But I want this to be parameterized. And that's where the parameter here comes in with C#. So when I'm defining a method, I can then have some parentheses, and inside of the parentheses, after the method name, I can have 0 or more parameters. Every parameter consists of a type and a name for that parameter. So the name of my parameter is args, A-R-G-S. That's short for arguments. These are the arguments that are being passed to the application. And the type for this parameter, because C# is what we call a strongly typed language, every variable, every method itself has a type. In this case, the type of this parameter is a string array. So these square brackets after the word string tell me that this is an array. So first of all, what is a string? It's a sequence of characters like hello Scott. And what is a string array? A string array would be a collection of those strings. So I can have 0 or more strings being passed in as args. So any arguments that I type on the command line that I want to pass to this program will arrive in this args parameter. Now, perhaps you've worked with arrays in other languages. Arrays are a popular data type that you can find in many different languages. And any language that has arrays will typically provide some feature that allows you to access a specific item inside of an array. So someone might pass me 3 arguments, and how would I access specifically this second element in that array of 3 arguments? Well, in C#, I would do that by saying arg, and then in square brackets, 1. So the way I would read this is args sub 1. And it can sometimes be confusing to someone who's new to the C# language. Why is the second element of the array number 1? Well, it's because in C# we have what's called zero-based indexing. When you index into an array to access a specific item, the first item in that array has an index of 0. The second item has an index of 1, and so forth. So arg sub 1 would be the second item. What I expect to do is pass to this program just a single name. A single name as an argument. So what I expect is that args sub 0 will contain the name value that I want. So what I want to do is build a string that consists of this greeting, hello, and then instead of hard coding the name here, I want the ability to place args sub 0 inside of here. So one way to do that is to say, let's take the string hello and a space, and then add to it args sub 0. So now it can be hello Scott or hello Alan, whatever I want, and then add an exclamation point. So what I'm doing here is known as string concatenation. I'm building a string out of 3 smaller string pieces. So take the string hello, concatenate onto the end of it arg sub 0. That will also be a string because I'm dealing with an array of string and I'm accessing a single individual string inside of that array here. And then take the single character that I place into a string, the exclamation point, and tack that onto the end. Another way to do this in C#, something that can be a little bit easier on the eyes, is to use a feature known as string interpolation. With string interpolation, what I do is I place a $sign in front of the opening double quote for my string. And now what I can do, instead of using the string concatenation, which forces me to break up the string and use plus signs, math operators, what I can do is have a single long string, and anywhere where I want to place in some value into this string, I can just use curly braces, and this is where I want to place args sub 0. So when I'm doing string interpolation, I can place inside of curly braces what's known as an expression in C#. An expression produces some sort of value. So the expression args sub 0 will produce the value that is the first string in the array of arguments that was passed to my program. So once again, I should be able to say, let's say hello, comma, and then whatever parameter is passed to me, and then an exclamation point. Now, what I want to do is save this file, program.cs. Very important to save your file. And let's come back out to the command line and issue a .NET run command. Now, I've changed the source code to my application, and .NET run is going to realize that the assembly, the gradebook.dll file that it has produced previously, is out of date for the source code that has just been saved. So .NET run, when I execute .NET run, is going to rebuild my application for me, essentially run the .NET build command. And also when I run .NET run, I need to pass along a parameter to my application. So I want to pass along the parameter Scott, except here's a little tip. If I just say .NET space run space Scott, Scott becomes a parameter to the .NET CLI, not a parameter for my application. If I'm running a console application with .NET Run, and I have a parameter that I want to pass to the application, not to the .NET CLI, then I need to place a dash dash on the command line to separate my application parameters from the .NET parameters. So .NET Run dash dash Scott is saying, let's run the current project and pass along a parameter, which is Scott. And if I change this and say .NET Run dash dash Alan, I can now receive the text, hello Alan, which is perfect. So my application has a little dynamic feature where I can change the output or the text that's being produced. What happens if I just say .NET Run and do not pass any parameters? In this case, my application is going to have an error because I'm trying to access a parameter, or I'm trying to index into an array of parameters, and I'm using an index that doesn't exist. It's outside the bounds of the array. Essentially, the array is empty and has a length of 0. There are no parameters to the program, but yet my program's trying to get to the first element of that array, but there is no first element, so we throw an exception. As you're developing your C# source code, you'll probably run into exceptions as you're learning the language. Let's talk a little bit about how to debug this problem. Just to summarize what has happened here, I tried to run the program without passing any arguments, yet my program wants to access the first element in the args array, but if I don't pass any parameters, the args array is going to be empty. One of the responsibilities of the .NET runtime is to make sure that my program doesn't do anything that is obviously wrong. Trying to access a non-existent element inside of an array is something that is obviously wrong. So the .NET runtime will force my program to throw an exception. An exception represents an error condition. Later in this course, we're going to talk about exceptions in more detail. One of two things can happen when the runtime throws an exception. Either my program can handle the exception and say, yes, I expected this error to occur, or the exception goes unhandled, in which case it's going to halt the process or crash my process. The .NET runtime is not going to allow a program to continue executing if there's an unhandled exception, which is good because my program might be in a faulty state. It's operating under some erroneous condition. And if we just let it continue, it could do something terrible, like just format my hard drive. So the program is halted because of an error, and now I need to figure out why. When you're first learning the C# language, it can be very difficult just to stare at lines of code and figure out where a problem is. And that's why a debugger can be useful. A debugger can allow me to execute my program in a controlled environment and inspect the environment as I go along to try to find the source of a problem. So let me show you how to use the debugger. This can be invaluable as you're learning the C# language. So first of all, I want to look at this error very closely, and I want to especially pay attention when the .NET runtime tells me the line of code where this error occurred. So I can see this is in program.cs line 9. So coming back to the editor, this is line 9, and what I want to do here is set a breakpoint on this line. So over here to the left of the line number, where the little red dot appears, I want to click to make that dot appear less transparent. And that tells me I have a breakpoint set on this line of code. So now when I run the program with a debugger attached, anytime execution reaches this line of code, line 9 on program.cs, the debugger is going to pause the program and allow me to inspect the environment. So I can look at things like the parameters array. I can look at variables. I can see what's defined and what the values are. So let's go ahead and try this. I'm going to click on debug, and I want to start with debugging. That would be the F5 key if I just wanted to hit a keyboard shortcut. This is going to launch my program. So my program is now executing. I can see some log messages scroll by down here in the debug console. And I know I have hit my breakpoint because I now have a yellow background on line 9 of program.cs. Of course, these colors can change depending on your color scheme. But code is clearly trying to highlight this line of code as where I have paused execution. And if I know this line of code is throwing an exception, well, one of the first things I should look at is, what are the arguments? Because I'm trying to access arg sub 0, the first element of that array. And this syntax that is appearing here when I hover over arg sub 0 is trying to tell me that args is a string array and it has a length of 0. And that means trying to access any element in this array is going to cause a problem. Another place to see variable values would be over here on the left-hand side. Here's a list of all the variables that are in scope and in effect when I hit this line of code. So that's another place where I could see that args is a string array of length 0, so I should not be able to access any elements there. And now I know what's wrong with the program. It's trying to access an element that doesn't exist. What can I do? Well, if I wanted to just go in and start fixing code, I could click up here on this toolbar to stop debugging, so Shift F5. That also happens from the debug menu. I can say stop debugging. However, as we move throughout this course, we're going to be writing more and more code, and you might have multiple breakpoints inside of a program, and you might want to do things like continue execution. So if I press F5, the debugger would allow my program to keep running until it hits another breakpoint. I can also step through lines of code. I can step over and I can step into. That would be the difference between entering a method and just stepping over a method. We'll talk more about that later in the course. But if I wanted to move to the next line of code in this program, I could press F10 to step over, but I can see, oh, I'm not allowed to get to the next line of code. I have a index out of range exception. An index was outside the bounds of the array. Actually, the debugger has halted my program where this exception has occurred, which again is line 9 of program.cs. So I sort of know what I have to fix. I have to make sure that someone has passed arguments to my program before I try to use those arguments. What my program should be doing is make sure that there is an element in the arguments array before it tries to use it. And a way to do that is to walk up to the arguments and check a property named length. So every array inside of .NET will have a length property. And the way I access a property in C# is to use the dot operator, is what we call it. So I want to go up to this arguments array and then inspect a length property, and that's going to give me back a value. A value like 0 would indicate an empty array. A value greater than 0 would say, yes, there is something in this array. So let's write our first simple if-else statement in C#. I want to use the keyword if, and inside of parentheses, I'm going to use an expression if args.length is greater than 0, then yes, I have something in this array. In which case I want to execute the next line of code, which is console.writeLine, hello, and then the argument. And in order to place this console.writeLine inside of this if statement, so anytime it is true, I'm going to wrap that statement with curly brackets. So we'll talk in more detail later in the course about if statements and other conditional statements, but I need to say if and then have some Boolean expression that returns true or false. If this expression returns true, I execute what is inside of the curly braces here, and I can also optionally have an else. So what if that if statement returns false? What if length is not greater than 0? In that case, let's do a console.writeLine and just give a generic hello greeting. And now to see if my program works, let me go back to the debug menu or press F5 or even Control F5 to say, let's just execute this program. I don't need the debugger. And down here in the debug console, I can see the output hello, which is perfect. Now my program doesn't crash when someone doesn't pass it parameters. But the question is, how do I pass this program parameters now? Well, from the command line, it's very easy. Now I should be able to say .NET run and pass in the command line parameter Alan, and I get back hello Alan, which is perfect. And if I pass in Scott, I get hello Scott. And if I don't pass any parameters, I just get a hello. So my program is working well. But when I run with the debugger, how do I pass in those parameters? Well, you might remember earlier in this module, when I received the notification in Visual Studio Code that required assets were not present to build and debug this project, do I want to add them? And I clicked yes. There were a few important files that were added to the file system. So coming back to the Explorer view here in Visual Studio Code, the files that I want to look at were created inside of a new folder with a .vs code name. So I want to open up that folder, and I can see there's 2 JSON files inside, and these JSON files control what Visual Studio Code will do when I want to do something like debug or build my project. Let me open up launch.json, and there's a lot of information inside of here that we don't care about. I just want to call your attention to, in this configuration section, this arguments array. So these are literally the arguments that the debugger will pass to my application when it launches it under the debugger, or even when I launch the program without the debugger. So in other words, let's pass Scott inside of here, and let me press Control F5 to run the application without the debugger, and I should be able to get hello Scott out when I run without the debugger. But now let's try something else interesting. Let's actually pass 2 arguments, Scott and Alan. This would be from the command line like saying -- Scott and Alan. But in this case, I'm going to do this with the debugger. And I want to do this, and I want to press F5 to run with the debugger. And I'm doing that just because I want to show you what the args will look like when you do have a parameter. Now when I mouse over this, I can see args sub 0 is Scott, and args sub 1 is Alan. So yes, these arguments will have a length. If I hover over length, I can see the length is 2, and that means I can use arg sub 0 and arg sub 1 legally without getting an exception. So this is the type of information that you can look at with a debugger. It can be extremely helpful when you're trying to figure out why your program is not behaving the way you expected. Is there some value in an array that you expected to be there that isn't there? Those are the types of things that you can look at with a debugger, and I encourage you to explore and experiment with this debugging tool before you move into the next module. In this first module, we installed .NET Core and VS Code, and now we are writing our first C# program. We also found the first bug in our software. Now you could argue that the first version of our program requires a parameter from the command line, so it wasn't our fault that the program crashed when me, the user, didn't enter a command line parameter. But we really should write our software to handle bad user input, because since the beginning of time, users have given bad input to software, and they'll continue to do so until the end of time. So write your software to be careful with user input. Now in the next module, we're going to build on what we've learned here, and we're going to start learning the fundamental features of the C# language. And we're going to start by learning about classes and objects.